All right, are you guys ready?
Mm-hmm.
All right. Well, I guess we should get started. Welcome to Why Not Change the World, the RPI podcast, where we bring experts from different disciplines together to discuss challenges and solutions. I'm Reeve Hamilton, and on this episode, we're talking about building materials and supply chains. I'm joined by Mei Ling Loco, the director of the Building Science program at Rensselaer.
Hello, everybody.
And Jennifer Pazor, an associate professor of industrial and systems engineering at Rensselaer.
Hi.
Thank you for joining us. And May, we'll start with you. Can you tell us about your research, which is focused on essentially growing building materials from agricultural waste, I think. Do I have that right?
Yes, you do. I usually say I take what I think is arguably one of the world's most underutilized resources in the form of waste from agriculture and figure out ways to bind them with bioadhesives, which I think is an emerging group of materials in order to produce healthy building materials.
And why would someone look to do that?
Yeah, it's a great question. I mean, I think firstly, it's a question of scale. We produce about 150 megagrams of agricultural crops every year, of which only a third ends up on our plate. The majority of which basically either gets downcycled or it's burnt in open air. So there is the need to find, and take the actual value of these really sophisticated materials and figure out ways for them to satisfy some of the most pressing needs of our time. For me, one of the most pressing needs is in the building sector. Not only is our buildings the largest consumer of energy, but increasingly, we spend over 90% of our time in buildings. I mean, I don't know about you guys, but mine is probably closer to that. And that means that what we surround ourselves with in terms of materials play a disproportionate role in terms of affecting our health and well-being. In many ways, I think it's just as important as, what food does to our bodies, the air we breathe in, the environments we surround ourselves in. And I think, given the fact that we're experiencing so many challenges in terms of getting increasing building materials from increasingly rare and difficult to extract and processed resources, this is right at our doorstep. And so, I began looking at it probably about 8 years ago, and it's been a wonderful experience. I think we're only beginning to scratch the surface.
Well, what are some materials that you work with, just so that people have a sense of what we're talking about?
Well, the first material I ever worked with was coconut. How wonderful a material. Everybody's familiar with this coconut boom in terms of health fads. You drink coconut water, you put coconut oil all over your skin.
I appreciate that you think I'm at all familiar with it.
You're not? Well, Jessica Alba drank the coconut water and all of a sudden everybody was growing coconuts for coconut water. And where I'm from, so my father's from Ghana, my mom's from the Philippines. Those are huge coconut producing countries. And there's a lot of small scale traders that sell these husks that contain really yummy coconut water in cities. They're not allowed to actually dispose of the husk in municipal waste systems because they're so heavy that bulk density is quite high. And they're not allowed to figuring out ways of burning it in open air. So they do this illegally at night in cities, which is a huge air pollution problem. And so I, looked at that research area that we were starting to start at CASE, which was focused on agricultural waste. And I thought, I need to somehow connect this back to where I'm from. And coconut husk turned out to be one of the most mechanically robust natural fibers. And this sort of substance, it's sort of a dust-like substance that holds the fiber and the husk together, was an amazing bioadhesive, meaning if you melted it at specific temperatures and pressures, probably half of what you see in like plywood industries, they basically melt to form a very uniform matrix and you get a really strong material. So coconut was the first, and then I got very sick of coconut, still finding my way back. And I'm mostly working right now with mycelium. And mycelium is the vegetative state of fungi. It's found all over under our forests, really. And they do all the work. They go in search of water and nutrients, and they, help mushrooms flower and other types of plants to survive. Instead of doing that under the ground, you do it above ground and feed it with agricultural waste, with food waste, with biomass from invasive species that are proliferating our cities. And you can grow an inert, non-toxic material. All you need is 5 days. So we've been taking waste. Upstate New York is a lot of hemp fibers, corn from the Midwest, and feeding it with these materials in order to develop things that range from insulation all the way to particle boards.
And so what are some challenges to making this a broader movement, if you will?
I think the biggest challenges are, firstly, this is waste. So the quality is quite poor. People don't care about what the quality of their waste is when they, throw it out into their garbage or it comes out of a factory. And then secondly, by and large, these material resources are produced decentralized, right? So they're distributed, they're produced everywhere. And so just, those two things, the quality and the fact that, the logistical transport of these materials to a site where it's going to get processed is so high, it makes it quite expensive. So those are the sort of the technical and economic challenges. But I've come to also realize that the social and the cultural aspects of taking waste and figuring out how to make people value them is probably some of the more subtle, more intangible aspects that we need to address. And how do you get waste recycling to be aspirational as opposed to punitive, where if you don't sort your trash a certain way, you get fined or nobody picks it up? How do you make it something that people aspire to and part of their daily lives? So that's probably one of the biggest challenges for me.
Jen, now this is where you come in a bit. Can you tell us about what your research is, and then we'll get into how it might fit in with all of this?
Yeah. So, one of the things that I think is inspiring about what May's working on and is similar to what I'm working on is this idea of underutilized resources. And so just like in the building space or agriculture, there's underutilized resources. There are underutilized resources all around us, and the research I'm specifically most interested in is within the supply chain. And so the supply chain is what enables us to get all the things that we enjoy in our lives. So from medicines to the smartphone you're checking to the food we eat, it doesn't just appear. And so instead there's all of these different entities and processes and systems and data that enables us to get those things. And so my research is interested in how do we do that? How do we design supply chains? How do we operate them? How do we acquire the resources we need? And specifically, I'm focused on more distribution, which is on the edge of the supply chain that's closest to the customer. Mm-hmm. And so when we look at distribution, right now it's a really exciting time and also a very disruptive time in logistics and distribution. And we are to blame for that. We are demanding, we want our stuff fast and the variety and e-commerce. And that is actually really fundamentally different than not that long ago. So if you think back, even just 5 to 7, 10 years ago, we all were willing to go to a store to get our stuff. And so if you think about that, that's a very centralized demand location. Now, all of a sudden, we're very decentralized, similar to May's agri-waste. And so we want our stuff delivered to our houses in small quantities, and that is very different than what was happening before. And so my research is interested in, given this is happening, the demand is changing, how are we able to respond to that? How are we able to design supply chains that are able to meet what I call today's customers, the modern customer? And so one area that I'm really interested in that I think has some overlap also with May's work is on-demand platforms and how these are systems that just connect and provide visibility into both supply and demand in these systems. And the beauty of this is they're able to tap into underutilized resources on demand. And so I think there's some interesting synergies potentially with what's happening in kind of the logistics and distribution space that could be a potential solution to some of the agri-waste stuff that May is working on.
Yeah, when you say an on-demand sort of distribution platform, what should people have in their mind when you say that? What are the things involved?
Yeah, so there are a number of companies that are doing this, but I think the best way to think about this is, have you heard of Airbnb? Which is basically Airbnb owns no resources. They don't own any hotels, but yet they match people that need a space to stay with people that have some sort of resource that place. Those same types of on-demand platforms are happening in the supply chain. So one area of research that I'm interested in and I'm working on is a space called on-demand warehousing, which is very similar to Airbnb, only for warehousing and distribution. So the idea is, if you think about a warehouse, if you've ever driven on some interstate, they're usually these huge, massive, like monolithic buildings. And once you build them, you have to think about all kinds of things. Like, okay, for 5 to 10 years out, what is my demand going to look like? What are my requirements going to look like? And then if you look inside of those buildings, they're big, solid, like static, monolithic things. But if you look in day to day, there's lots of seasonality. There's lots of underutilized space. There's lots of underutilized capacity. And so what we're interested in, and there are companies doing this, is how can we tap into that? And so instead of just building your own warehouse or owning your own resource, what if I accessed resources on demand? And so the research here is there's a lot of benefits to this. They provide flexibility, agility. However, they're fundamentally different than what we used to think about when we thought about owning our own resources. So the price structures are different. How often you need to make a decision, what types of decisions are different. And so the research we're doing is about kind of new math or new optimization models and algorithms that need to incorporate all this new phenomena into the decisions that people want to make.
And so how do you see these two areas potentially working together?
Yeah, I mean, I think I was thinking about it when, I first came across Jen's research, was the fact that, people produce waste every day right in their kitchens, right? And you may not produce as much of a quantity as is needed to grow, a bowl or a wall panel, which is stuff you can do today using mycelium. But how do you match that resource with, say, a bulk, much more light, much more widely produced agricultural waste that is produced in your neighborhood or in your region? I came across this in Liverpool in the United Kingdom, when I was working with an urban farming group that sort of descended from, some of the most efficient urban farming practices after World War II. Basically, when the British government said, do not bring any more food in, we've got to use these ships to bring in weapons, they gave them land, the allotments, and they basically had to farm for themselves. And I think, obviously that has sort of, disintegrated, but it has also informed this really robust urban farming practice. And they, en masse, they basically occupy school plots, they occupy public space, and they grow different types of crops. And they have quite a lot of waste that's produced on a much larger scale. And that could supplement, say, more high-quality food waste that we're producing on a much more regular basis in our home, so that you did have a composite of materials in order to grow something right where, you live. And then there was also another scenario, so that's sort of the domestic to neighborhood scale, where, if you're looking at disasters that are happening in cities where you need, to assemble or build something really quickly, it's a much larger scale of, assembling sort of a structure to inhabit the conditions that the mycelium would need to grow all of these materials. But how do you, first of all, get all of the material resources to that site where you're producing? And how do you get volunteers and coordinate them in ways that are incredibly efficient so that, time and space is used very wisely, and if it needs to shift location, that can happen. And that sort of emerged as sort of a conversation point between me and Jen, and we're, working towards that in a few ways.
Yeah, and what to me is exciting about what she's explaining is you're explaining basically supply chain problems, right? So how do you get resources at the right place at the right time in the right quantity in the right quality? And that's, fundamentally a supply chain problem. And so that's exciting. And then I would also say more broadly, what you're describing as challenges are similar challenges in the supply chain space, which is around coordination. So how do we coordinate that we have different resources and different demands? They're there, but they're not, connected,
matched, yeah.
And they're not visible, and they're not utilized in this way because we're missing kind of that middle piece. And so I think both from an application perspective, some of these are supply chain problems, but also from a methodology perspective, I think even though my methods have been applied mainly to supply chains, I've been excited to think about, wow, this could be applied to innovative building materials.
And when I assume it's not as simple as just, we'll just create an app that, you can say, you need a mycelium bowl, I've got one over here, let's bring it over. How do you begin to tackle these challenges?
Yeah, I mean, that's a great question. When I started a company, when I finished studying at RPI in Ghana, I was really interested in actually producing coconut building materials in the city. And I wanted to involve a lot of these coconut urban traders. So my idea was to collect all the husk, where there were sort of piles around where they would sell, and then bring them to a factory in the city and process them. That is so inefficient. They're so heavy. Your truck is going to spend so much fuel. There's traffic. I mean, it's crazy. And when you begin to look at what makes that system efficient in terms of, people are using very, small vehicles, sometimes on foot, they're pushing wheelbarrows, or they're on, motorcycles that have stuff that allows them to carry husk. These are little things, features that make that very efficient. And I realized very quickly that, you had to sort of administer some type of waste pre-processing, so either shred the fibers down right where it's produced, and that also helps with its quality, because mold, and when it rains, doesn't form on the husk. When they're in the fibers, they easily dry out. And you can transport this light fluff of fibers on, smaller vehicles to a site, and many more people could participate because they already have those vehicles. So for me, it starts with looking at the way things are done, and what are the essential features of that system that make it successful, and not trying to copy sort of what we already know. Like when we think of plywood industries, I mean, these are super engineered infrastructures. Those machines take 5 minutes break a year. They need pressure. They reliable production processes. Versus you look at agro-waste, oh my God, a coconut grown in Ghana is different from a coconut grown in Sri Lanka. I found out the hard way. So already if you have that type of feature, then how do you somehow administer some form of quality control? And some innovation in the production or processing is key.
Yeah. And I mean, what I think is really right on point of what May is saying is technology may help, and that may be a part of the solution. But what she's describing is operationally, we need to get and look operationally, how does this work? What are the decisions? How can we use data and technology, but in the right ways? And so really taking an analytical, systematic, operational approach is where I think is exciting. And it's why I'm excited about the field of industrial and systems engineering, is that way of looking at the world. And technology plays a role. I do think apps and things like that are going to come into this space and are already in that space. But the development of the app is the easy part. It's the implementation of that from a process and an operational and a human perspective. And if you have an app that no one uses, how much does that influence? And so looking at this much more systematically and understanding the trade-offs in these systems, I think is the huge challenge.
Yeah, I love the fact that you said human, because I've, in the field of design, participatory research is becoming a huge thing, but is always done on surface level. Like people aren't able to put themselves in the feet of their ideal users and say, okay, how would I participate or, perform these tasks on a daily basis? So just last week in Berlin, I was design sort of a next generation kitchen where you would upcycle your waste from making lemon water or making coffee in the morning to grow either some types of mycelium food or mycelium products. And we were trying to enact rituals, right? So rituals that were integrated, as common as setting a table or washing the dishes. And it is hard. And from learning from that performance, you realize, my God, there's so much more work that needs to be done, not in terms of design, but also educating and allowing users to give feedback in terms of how, they would operate in that system. And that's, I think a huge part of the problem that when, you're inventing something, you're never really looking, at that in as much, focus.
Well, and that gets to a question I wanted to ask you guys, which is just you both are working in spaces that have sort of long-standing traditions and histories and ways of doing things, and how does one begin to break those down and bring in something new?
Yeah, I mean, so I will say, someone that studies supply chains, it's kind of a traditional business, and I'm a big believer that the supply chains of the future are going to be fundamentally different than the ones today, and you're already seeing that. And there's definitely people resisting, companies resisting. What we're seeing in the space of supply chains is the Amazon effect, that Amazon has come in and said, I'm going to get your stuff in 1 day or 1 hour, and this is now what us as consumers are expecting. And so there are some business forces that are really pushing much more collaborative, open, dynamic systems that I think is the way of the future of supply chains. It's happening. We're seeing some of that, but the growth in that, I think, is in order to be efficient, to do the business at the scale you want to do the business at, you need to not just think about owning your own resources. And so one interesting push recently has been kind of more of a business push that is generating some change in this space.
Yeah, I mean, that's a great point. When you talk about owning resources, both in, the field of architecture and in the actual materials I'm working with, it's, to me, so important to realize that nothing that comes out of one process is, waste. It's a resource, and fundamentally shifting how you think about material like plastic is not bad. It's only bad if we don't rethink how it actually gets transformed to something else that doesn't harm or have a negative effect on our environment. I think, for instance, in the discipline of architecture, we cannot begin to see clients as just people who receive. They actually play a huge role in how our systems work. So that shift of thinking about your client as a participant versus, so they're in some essence experts, engaging them is key. I found, extremely useful models of academic industrial alliance, particularly between either outliers to very established ways of processing materials. I mean, I think of the agricultural corporations in sub-Saharan Africa, which are very, entrenched in global economic systems. It's very hard to do something that is not already well understood and supported economically. So these companies that take waste, the coconut husk waste in the city, they're outliers. And for them to partner with an institute like RPI, and that allows them to take on some risk in terms of developing a new product or gives them cultural or financial capital, is key. And it's not just a one-way street. There's a lot of expertise that is offered on the way back. And so that shift of, somebody's always just receiving has to change. And I'm very excited about that. I think there are a lot of businesses here in upstate New York surrounding RPI, including Ecovative, which is an amazing mushroom packaging and food company now, that, are supporting these type of new alliances, not just with academic institutions, but with startup businesses all over the world. So I think those type of partnerships allow you to see a different end goal in terms of research and different ways to actually pursue, these research pathways.
Well, as you both keep working on these issues separately and potentially in collaboration, what does the future look like? How will, when you think about where you're headed, how will life look different as a result of the changes you guys are working on?
I imagine that we will develop new types of technologies that would help us process so many things coming out of our homes. I mean, my CLM is, to me, just an amazing flag bearer for this idea, but there could be many other technologies that could help us transfer materials right on site. I think, on-site 3D printing on a large scale is exciting. I think robots and our relationship with robots can change fundamentally to helping us transform waste in our homes. And I think that we would develop some kind of independence in terms of growing our own food. In our neighborhoods, I think there will be a different economy of producing stuff on a daily basis versus getting it from your neighborhood. I think food sharing and material sharing is going to be increasingly important. I think we would own less in that world. And that's exciting to me. Also super challenging as well.
I mean, I'm also excited, and I will say this is, lofty and long-term, and, this will take massive amounts of knowledge and experts and people to do, but I really do envision long-term supply chains and the way we produce and consume things to change. I think we have gotten really, really good at mass production, which taps into economies of scale in a very centralized way. But there's lots of forces, whether it's waste and circular economies, whether it's what we want as consumers, has pushed the demand side to be different. And so there's a long ways to go, because the challenge is, as you're talking about getting all these coconut husks in an efficient way, is there's inefficiencies in kind of this decentralized approach. If we think about how we did it well in a centralized approach, we can't just necessarily take that and then transfer it to kind of the more dynamic and decentralized. But I think that's exciting, and I think there's research to be done there, and it's definitely multidisciplinary research. And there needs to be lots of people in lots of expertise looking at this. But I do think it'll change so that we are maybe producing things not just in a couple locations throughout the world, but like in every house we're making what we're consuming. I think that's exciting. I think there's lots of
So every
challenges.
Consumer becomes a producer.
Yeah, and I think that's cool. And that's one thing that's really inspired me about May's research, is like thinking about that and thinking about what do we need to do to make this happen and to make this scale, which is cool.
Yeah, how did you come to be aware of each other's work?
Well, it was sort of in the most organic way possible. We were having a meal and a drink, and I think, we were talking about each other's work, and I realized, oh my God, like there is some kind of logistical and distribution aspect to Jen's research that could truly satisfy some of the biggest challenges I'm experiencing in this. And at the time, I was thinking about that as a business owner, but it is actually an amazing research topic that we could carve out, in terms of bringing in students and other collaborators here on campus to, latch onto and investigate.
Yeah, and so that was kind of our origin. And then one of the things I thought has been super cool about being on RPI's campus is, May had me in her studio class and, was thinking about facilities and how you design them. And I also teach a course on facility design, only in industrial and systems engineering. And the light bulb went off. Like, we're looking at very similar systems, but in a very different way. And that, to me, is exciting, to think about buildings and how we operate them and how we design them and how we use them. There's huge overlap between architecture and building science and industrial and systems engineering in a way that I never really saw until, kind of being aware of May's work and the broader work on campus.
I forgot about that. You came to one of our building science studio reviews, and we were focusing on Walmart, and basically a lot of these Walmart buildings that are actually being, decommissioned and becoming empty structures. What do you do? What would be a retrofit solution for that? And, in building science, there's a huge focus on the building envelope, if you like, the skin of the building. And there's where a lot of innovation in terms of energy and sustainable building systems are happening. But the conversation with Jen kind of pushed it in a direction that I was very, very inspired by, which was looking at how do you reorganize the building so that there could be buffer spaces that weren't just about operations, but about energy efficiencies. And so that ability to look into the actual guts of the building was key. And I think there should be more overlap between industrial engineering and architecture and building science in general. But yeah, that different perspective really, transformed the direction of the way the students were working. So thanks for that, Jen.
Thank you.
Well, and thank you both for continuing your conversation here on the podcast with us. It was a pleasure to have you on.
Thanks for having us.
Why Not Change the World is recorded in the Soloist Suite at NPAC, the Curtis R. Preem Experimental Media and Performing Arts Center at Rensselaer Polytechnic Institute. Thank you to the NPAC staff for their assistance, and thank you for listening.